Okay, so just as a quick recap, this is what it looked like. This is all the source code that we have, right? We have the aspect, a couple of instance variables. We have our point cut that defines where we're going to inject. We have our advice that tells us what we're going to do. It says before. We could also do after, or we could do around, both before and after. Okay? And we're doing basically your regular expression check along with an exception, throwing an exception if there is a problem. Sorry? Oh, the matcher, sorry. Yes, there is a couple of import statements on the top. Apologize for that. That's the Java regular expression matching, regular library. Okay, the authorization check, we can do the same kind of idea. So imagine this. You have an old application that doesn't do authorization checks on the server side. Let's say, for instance, you have a RMI interface, or you have a web services interface, right? You need to control that. So let's say that for that particular interface, you have a whole bunch of public methods exposed from something you call a service object. Okay? This is just theoretical, but it applies, right? What we're doing here is we're saying anytime that a service object is executed, for that particular service object, anytime there's a public method that's executed, throw it through the access checker, check the user that's there right now, and that object. And if they have correct access rights, then you go on, and if they don't, then you throw an invalid access exception. Okay, so this is another instance of how we could use AOP to fix an application that already exists. So here's a question to you guys. Can you think of any other areas where you could see AOP being used for security? And we have bribery, smaller forms of bribery than before. Snickers, little Snickers. Excellent, excellent. I think that's an excellent question. I think the question alone deserves a chocolate. What if you don't have the source code alone? That's one of the best parts of AOP, and we're going to show you this again later. But if you have the compiled code, if you have the jars in Java, or you have some kind of library, you can actually use AOP to advise on compiled code. So you don't have to search through source code. But what are some other applications? So we've talked about input validation, we talked about authorization.
Can you have time and state at all?
Can you affect time and state? You mean like from a concurrency standpoint?
Absolutely, like synchronization issues or anything.
Yeah, so there is a bunch of controls put in for synchronization. Like these aspects are singletons by default, but you can have them so that they're on a per object base or per thread basis. There's a number of ways that you can actually control that. Okay, so you have the flexibility to be able to work around concurrency issues. Can you use it to secure session management? Another excellent, everyone's asking excellent questions. Yes. Suppose you don't have secure session management. Even authentication, right? The application doesn't have these controls. You can wrap it so that any call that comes into your application, you make sure that you have an authenticated principal, and that authenticated principal has a valid session. And if they don't, then you send them to the authentication page. You redirect them. Any other ideas? What about logging and monitoring? Sorry, did someone say something? Excellent, logging and monitoring. Okay, he still gets a chocolate. Logging and monitoring, right? Logging. It can instantly log every performance or every time that a certain method is executed, before it starts, after it ends. Exception handling, I think we talked about briefly, right? So basically all of those security controls that we think of, in many cases we can throw into aspects. Now, someone brought up a good point that certain cases like specific exception handling or very specific logging, you might want to still keep in the source code. But we can try and get a lot of it out of our methods. And what that means is we can function or concentrate on functional requirements, right? On actual core business logic, and take out all these other things and throw them into aspects. So we're going to get a lot of objections. I've seen a lot of objections. I wrote an article about this for Security Focus, and I got about 6 comments that said the same thing. Listen, we can do this already. OOP already does this. People are just trying to reinvent the wheel and, grab a lot of credit for it. And, okay, fair enough. You can do anything with OOP. But just remember, before OOP, you could do everything that you can after OOP, right? Many of our operating systems are written in C, not C++. But that doesn't mean that C++ doesn't afford us better design. And that's the idea behind AOP. So let's think of this. 10,000 objects, okay, massive application. They don't necessarily have anything in common except they execute this method 1, all right? And they all do business logic. Then things evolve. We realize we need to put authorization checks on every instance of that method 1. So we do, 10,000 times. This is what, in the AOP world, they call code scattering. Okay, these are concepts that go outside of what's supposed to be done for the business logic. So things like transaction management, a lot of security concerns, logging and monitoring, a lot of exception handling. It pollutes the code base. And there's actually been statistical correlation between the amount of pollution that's in there and the number of defects we have in our code. So the idea is this. If we took it out, right, we could focus specifically on just the do work part. Now, again, let's assume we have this, and then later on we decide we want to add transaction management. Well, 10,000 times we have to do the start transaction. Okay? So hopefully you're starting to see here that even if it's not solving a new problem, it's a different way of solving existing problems. Right? We can take all of this out and have one aspect to handle it all. Right? And just imagine how much cleaner our code is and how much better we can modularize it. And it gets to the idea of coding securely versus coding security, right? We still want people to code securely. We don't want them to break, to give you cross-site scripting vulnerabilities in the application. But what we can do is we can take a lot of the responsibility for security functions like access control, like session management, like exception handling, like input validation, and give it to a few core people who understand it really well, right? And that's where the true power comes in. The next one is AOP is unproven and unstable. I got this a lot, actually. Some stupid technology, no one knows how to use it. We can do other things like servlet filters. Yeah, you can do servlet filters in the presentation tier, but you can't do them anywhere else. AOP has been around for 11 years. Aspect-J has been around for 11 years. It's an official Eclipse project. AOP is now available in Spring, right? If anyone's familiar with the Spring project, Spring framework, it's available in JBoss inherently, and it's going to be available in WebSphere and WebLogic. And in fact, some parts of WebSphere inside the actual development uses AOP concepts. We're going to get to that actually, but excellent point. .NET as well, right now. AOP is unproven and unstable. Well, IBM has said AOP is vital for our survival. Microsoft, actually, we just found out today Microsoft is no longer researching AOP for .NET. It's actually available for Visual Studio 2005 for C#, okay, from Microsoft itself. There have been third-party add-ins before, but now Microsoft themselves are creating it.
No, it's called Aspect AOP for .NET.
AOP for .NET?
Yeah.
Are there multiple kinds?
There are multiple kinds of them, but Microsoft has primarily brought this out for C#. They've not yet brought it out for the other ones. There are some that are, and I don't want to jump ahead into it, but we'll talk a little bit about it in a few slides for sure.
Industry. So at the last two aspect-oriented conferences, Siemens, Hitachi, SAP, and Motorola presented cases where they were using it in their applications. Okay, so it is being used in the real world. This is not just theoretical fluff anymore. Performance overhead. Going back to the original question. Okay, there's two ways of doing AOP. One is doing it at runtime, like what the Spring framework does. It doesn't change the way that we compile code. Well, then that becomes an issue because we actually start looking at methods and we look for, at runtime, what's the signature of the method, what are the parameters of the method, and that adds a lot of overhead. Okay? So that is something that is legitimate concern. But when we go to compile time weaving, which is what Aspect-J does, remember our set name example? Well, in set name, what would have happened is in the bytecode for set name, before it actually executed, it would have pointed over to our aspect. And so that was a one-time, quick, not major performance hit, right? And there have been benchmarking studies on that as well. Any other objections you can think of? Reasons why this is not a good technology to use, or no one would